Sampling is defined as a process in statistical analysis where researchers take a predetermined number of observations from a larger population. Advantage of sampling is that it has lower costs and faster data collection than measuring the entire population, and can provide insights in cases where it is infeasible to measure an entire population. The method of sampling depends on the type of analysis being performed, but it may include simple random sampling or systematic sampling. The sampling process helps create unbiased samples by ensuring that the population of interest is defined before a sample is drawn. Once the population is defined, a sample is selected that represents the entire population. Data is then gathered from as many elements as possible. For greater context, steps in the sampling process include defining the population, framing the population, choosing a sample design or technique, determine the sample size, and executing the research. In step 1, we need to define the population. The first step of the process is where the researcher must specify the population to be studied. Population is commonly related to the number of people living in a particular country, or a group of people we want to know more about, such as our target market. For example, we want to know how much football fans are willing to spend on a sporting event, such as the Football World Cup finals. Our population for this research would include every person in the world who would want to go to the finals of the Football World Cup. In reality, there is no way we can interview every single person across the globe interested in going to the Football World Cup finals. However, we have been able to clearly define target population we would want to know more about. In the second step, we need to frame the population. Once the population is defined, the researcher develops a list of directions to identify the population so that a sample can be drawn. This is also known as a sample frame. A sampling frame is the source material or device from which a sample is drawn. It is a list of all those within a population who can be sampled, and may include individuals, households, or institutions. For example, we might decide that our sampling frame is every football fan interested in going to the Football World Cup in the city we reside. The sampling frame is not as large as the population, but it can still be a large group of people. Chances are we won't be able to study every single person interested in attending the Football World Cup final in our city. However, geographical framing is a good place from which to draw our sample. In the third step, we will choose a sample design or method. Using the framework developed in step 2, the researcher then decides whether to use a probability or non-probability sampling technique. Probability sampling techniques use a random process to select elements for the sample, whereas non-probability sampling techniques use judgment or convenience to select samples. There are benefits to both techniques. For example, if our sampling frame is approximately the same demographic makeup as our population, we would want to randomly select our sample by flipping a coin or drawing names out of a hat. However, if our sampling frame does not really represent our population, want a non-probability sampling to select our sample in order to get a demographic makeup that is closer to that of our defined population in step 1. For example, if the city where we reside has a lot more men than women, or a lot more people from a particular ethnicity when compared to the population of football fans interested in the World Cup final, then we would want to use non-probability sampling to select our sample in order to get a demographic makeup that is closer to that of our population. In the fourth step, we determine the sample size. Sample size is a research term used for defining the number of individuals included in a research study to represent a population. The sample size references the total number of respondents included in a study, and the number is often broken down into subgroups by demographics such as age, gender, and location so that the total sample represents the entire population. In general, larger samples are better, but they also require more time and effort to manage. However, if the sample size is too small, it will not yield valid results or adequately represent the realities of the population being studied. For example, if we end up having to go through 10,000 surveys, it will take us more time than if we only had to go through 100 surveys. But the results of our study will be stronger with 10,000 surveys. Also, when selecting a sample, there are multiple factors that can impact the reliability and validity of results, including sampling and non-sampling errors. We should also consider the two measures of error that are almost always synonymous with sample sizes: confidence interval and the confidence level. In simple terms, the confidence interval tells us how confident we can be that the results from a study would reflect what we would expect to find if it were possible to survey the entire population. Whereas confidence level refers to the percentage of probability or certainty that the confidence interval would contain the true population parameter when we draw a random sample many times. For example, a 99% confidence level means that should we repeat an experiment or survey over and over again, 99% of the time our results will match the results we get from a population. Basically, the larger our sample size, the more confident we can be that their answers truly reflect the population. Key to note, for business, time is money, and all projects have an end date, so we will have to make choices and find a balance between what will give us good data and what is practical. In step 5, we execute the research. Once we know our population, sampling frame, sampling method, and sample size, we can use all that information to choose our sample. This is where the hard work really begins, as the researcher implements the research plan based on the decisions made in steps 1 to 4, and data is collected. In reality, most researchers never achieve a 100% response rate. Reasons for this might include refusal to respond, ineligibility to respond, inability to respond, or the respondent has been located but researchers are unable to make contact. In saying that, clearly defining sample, employing the right sampling technique, and generating a large sample can help to reduce the likelihood of sample bias and provide us with accurate data to understand the research task or problem we are trying to solve.